We're ready to go.
Hi, everyone. Welcome, and thanks for joining us. So for our distinguished lecture series, we have Rob Reich with us. I got the pronunciation right. First of all, thanks for joining the series that we are having every week. So keep an eye on it. I am John Sujanja. I am the ethics lead of the Institute for Experiential AI. And let me just jump into Rob's introduction. So Rob Reich is Professor of Political Science, Director of the Center for Ethics in Society, Co-Director of the Center on Philanthropy and Civil Society, and Associate Director of the Institute for Human-Centered AI in Stanford. He is the author of System Error, Where Big Tech Went Wrong and How We Can Reboot, and Just Giving, Why Philanthropy is Failing Democracy and How It Can Do Better, and also Digital Technology and Democratic Theory. His teaching and writing these days focuses on ethics, policy, and technology. So not to waste time, I'm just going to leave it here.
Great. Thank you. I just have great admiration for the incredible assembly of people that you're putting together here at Northeastern on topics of common concern. So I'm going to talk about developing a code of responsible conduct, the idea of community norms or professional norms amongst AI scientists, AI researchers, developers. I come to you as a philosopher, and in that respect, I'm going to try to bring a particular kind of philosophical approach to thinking about things at the intersection of ethics and AI. This is a famous painting of Socrates, and the kind of orientation I bring is mindful of the fact that in my experience over the past decade hanging out at Stanford with, of course, the amazing group of people in the computer science department, the engineering quad, just a short walk away from the main quad where the humanities and social sciences are, the typical experience of being a philosopher, for those of you who are philosophers, I wonder if this is the same for you, when you show up in a room of people who are engineers, is that when the philosopher arrives on the scene, it's as if the ethics police have shown up, and it's time to slow down and have precaution and maybe not build at all. And the kind of orientation that engineers typically have, in my experience, to their initial encounters with philosophers is that they are a drag on technological innovation, a brake on scientific progress, and in that respect, oftentimes much more like the Eeyore in the room, and in that respect, a kind of, an unwelcome presence. I want to try to bring a different orientation to thinking about the role that philosophy can play in conjunction with engineering, with conjunction with AI, which is rooted in what I think of partly as a Socratic approach, and partly as someone who's distinctive, or kind of, my own orientation as a philosopher is as a political philosopher. So political philosophers often get tagged with the idea of aspiring to be philosopher kings or queens. And so another occasional stereotype that people have is when the philosopher shows up, it's for the philosopher to offer a pristine framework of whatever justice or something demands. And we offer it up humbly to our, sort of practical minded colleagues who are doing things in the world. And if they only have their entire behavior conform to our pristine frameworks, we can go back to our happy precincts of the philosophy department and commune at 35,000 feet with the level of the ideals. That's also not the approach I wish to take as a philosopher. Philosopher kings and queens, for anybody who appreciates democracy, is not an especially welcome approach. So the Socratic approach is the kind of approach I take, which is to try to explore a set of values that are familiar to all of us, a set of values that we all at least pay some lip service to and maybe often try to bring to life in our various personal lives, professional lives, and political lives, and then to facilitate conversations which take the form of Socratic provocations. And I have my own substantive views, but more than anything else, the role of Socratic provocateur or facilitator of conversations across disciplinary lines is what I see as one of the main aspirations of doing work as a philosopher in conjunction with computer scientists. And so in that respect, I'm going to give you the punchline of the talk right away, the provocative punchline of the talk. What I want to suggest to you is that if you begin with the fact that computer science is a relatively speaking young discipline, only really came into existence in universities in the 1950s and 60s, of course, a kind of outgrowth of decision theory in the couple decades prior to it. formalized within university life and as a field of study in the 50s and 60s, people who had basically no power in the world for the 4 or 5 decades afterwards. They were hackers in the garage, tinkering away in various ways through a variety of AI winters. And really only in the past 2 decades have people who are computer scientists acquired wider power in the world through the technological innovations that have been brought to fruition, as it were, in the marketplace, and then have transformed so many aspects of our lives. Now, as a young profession, my basic claim is that the development of professional norms of coordinating amongst practitioners, researchers, developers, scholars, what would count as responsible conduct as an AI scientist, those norms are wildly immature. And the provocation I want to offer is that artificial intelligence research, development, and people who work in industry, it's like they're late stage teenagers. They have newly become aware of their power in the world, but their frontal cortexes are massively underdeveloped. And so there is a widespread social irresponsibility. And we would all do better to accelerate the development of a set of community norms amongst AI developers, researchers, scholars, in order to help facilitate what is now the undisputable power of technologists in the world to be one of the most important agents in shaping the force of technology for better rather than for worse. I'll get into much more detail about that in a second, but that's the punchline. Now, I mean that partly as, for any of you who are AI folks, a little bit of an insult in a certain respect. I'm choosing my words carefully there. I want to try to redeem the insult in a minute and get you to tease out some of the implications along the way. Okay. Well, this is just a trend line of computer science majors over the 2010s, the usual explosion in majors. I like to say sometimes, and I think this is true, I'm guessing this is true at Northeastern as well, computer science is the major that ate all the rest of the majors at Stanford over the past decade. Massive numbers of students majoring in computer science, the largest major on campus, largest major for men, largest major for women. Nearly 40% of Stanford undergraduates now major in engineering, 33% of them major in computer science. It's not rocket science to understand why this is. There's extremely lucrative careers on offer if you get a computer science degree. And to the great credit of people who are doing computer science, there are ways in which getting the technical skills that a computer science major affords gives you an opportunity as a very young person, 19 years old, 21 years old, 25 years old, to have extraordinary influence in the world with your skills. And I think back to the time that I graduated from college about 30 years ago, it was a kind of mystery to me that I never met a freshman in my undergraduate class who said, I cannot wait to become a management consultant when I graduate. And yet 50% of the graduating class applied for a job at McKinsey, Bain, et cetera, et cetera. And no one who did that thought that they were, acting on behalf of the world's interests or try to create great social change in the world. Yet many computer science majors think reasonably that as a 21-year-old, a 23-year-old graduate, their coding skills can be deployed for some type of socially beneficial project. And it is true that you can code away over the weekend, roll your product out to 1 million or 1 billion people and affect the lives of people. There really is a kind of important power that these technical skills afford. So I have enormous admiration for computer science students. No, I don't begrudge the success of the major, but I want to see these professional norms develop more quickly because it's a young field. All right, so at Stanford, I and others have been trying to harness, as this New York Times article put it in 2017, 2018, there's an ethical dark side about computer science. Of course, in 2016, with the Brexit and then the election of Trump, all of the techno-utopian attitudes that had attended being a computer scientist from the 2000s, maybe early 2010s, these great sort of mission statements of the big tech companies came under enormous scrutiny. The privacy abuses, the amplification of misinformation, disinformation, hate speech, automation that displaces workers from their jobs, and then various forms of algorithmic bias and unfairness. All of these things came to the fore really in the mid-2010s. And there was this great backlash against big tech and in certain respects against computer science, which had been a hothouse for people gaining extraordinary technical skills, but which hadn't had the opportunity to reckon with their extraordinary power in the world. Or if you wanted to take the language of an economist about this, it is a familiar pattern over the course of 200 or 300 years of history that the private marketplace, well, first powered by basic research that tends to take place in universities, and then with private capital that gets put behind the commercialization of the fruits of basic research and brings these products in some form or fashion to bear in the market. After these products get taken up at large scale, the market tends to consolidate with a few large players. And once these things are used by millions and billions of people, they tend to develop what the economists will call negative externalities, the unintended consequences of developing something that are then reaching great scale. And at that point, the rest of society tends to wake up, the regulators get into the game and try to steer the development of whatever this new technology is for the social benefit while trying to contain or internalize some of these externalities. That's kind of where I think we are at the moment. And the efforts that I've been making at Stanford have been to try to join together the fields, the disciplines of philosophy, of social science, and of computer science. This is a class I've been teaching for the past 5 years. It'll launch again in January. We have about 350, 400 students who take it. I teach it with the most popular professor at Stanford University, the computer scientist Mehran Sahami. He teaches CS 106A, the Introductory to Computer Science course. It enrolls something like 90% of the undergraduate body by the time they graduate. And he personally has instructed about 60% of the past decade of Stanford undergraduates, which is a kind of mind-boggling statistic. Teaching this class for me, 350 people, is the largest class by a long shot that I've ever taught. Teaching it for him, it's like teaching a boutique seminar because he typically enrolls like 900 or 1,000 students in Introduction to Computer Science. And then there's the policy person who comes from experience in the Obama administration and is a really first-rate social scientist. So it's the only class that we're aware of, at least at Stanford, that integrates into it technical assignments, policy memos, and philosophy papers. The computer science students that we enroll are massively anxious about having to write a philosophy paper. The philosophy students we enroll are often completely clueless when it comes to the technical assignments. We have to get an array of teaching assistants from different parts of campus because the computer science students can't grade the philosophy papers. The political science graduate students can't grade the technical assignments. We're patching together this kind of course to try to integrate a new framework for thinking about the training of technologists. Now, that yielded 2 different books. One of them is a kind of outgrowth of the course. That's the teaching team on the right. And we wrote this book last year called System Error that John Su mentioned. I've also edited a book, this came out the same year, called Digital Technology and Democratic Theory, in which political philosophers, social scientists, and technologists came together through 3 workshops to have conversations about these intersections to try to develop some common language for thinking about our work. Okay, so that yields what I want to talk to you about today. I want to say, I think, I'll say this in a dramatic sense, but I think it's also not especially controversial, not especially grandiose. I think that there are 2 extraordinary revolutions, scientific revolutions of the 21st century that will determine something like the fate of the species, the human species. Those are the bioengineering revolution, gene editing and CRISPR, and then artificial intelligence. Both of these things call into question the very nature of what it means to be human. If through genetic editing, humans can intervene in evolution for the first time in some durable, permanent way, finding all kinds of ways to edit the germline itself, that's an extraordinary power for humanity to have. And of course, with respect to artificial intelligence, especially just in the past couple of years with these big foundation models, large language models, all this talk about creeping towards artificial general intelligence. If we humans manage to create super intelligent machines that reliably and systematically across a broad number of domains outperform human intelligence, that will also have profound implications for what it means to be human. So unless we find a way to harness these 2 revolutions to human interests themselves, rather than allow them to be a kind of thing that runs beyond the interest of humans, I think we have to find a way to steer these scientific revolutions, these technological innovations, to act on the benefit of humanity. I'm guided here in certain respects by this quote, which I'll give you without giving you the attribution first, give you a chance to take a look at it. the inventive genius of mankind bestowed upon us the last 100 years could have made human life carefree and happy if the development of the organizing power of man had been able to keep step with the technical advances. As it is, the machine age is like a razor in the hand of a 3-year-old child. Technology and science races ahead of the capacity of our social institutions and our human psychology to keep pace with it. And so we have extraordinary technical powers with, as it were, latent and ancient social institutions to guide them. Does anyone know who said this, by the way? Einstein, excellent. Einstein in, I think it was 1933. Not in 1932, kind of remarkable anticipation of the great achievements of science and technology over the past near century. So just what I said before, these scientific revolutions called to question what it means to be human. Though that's the task that we collectively face. It's a task that means we have to embrace more than just a technical or a scientific orientation, and we need to embrace a kind of skill set, a set of tools that come from outside of technology itself in order to think about accelerating these social institutions to manage the profound implications of these two revolutions. So what I want to talk about today is 3 levels of ethics, and then accelerating the development of community norms or ideas of professional and responsible conduct as an artificial intelligence researcher, scientist, or developer. The 3 levels of ethics, I'm going to say a few things here that will in certain respects be mundane and maybe not especially interesting to anyone with philosophical training. But for those without it, perhaps of some interest. And I want to anticipate for any of you who have, like in this room, mixed together already with philosophers and people with technical training. Usually when the philosopher shows up, another feature of discussion that people sometimes anticipate is, oh, the philosopher is going to talk about utilitarianism, deontology, and virtue ethics. And there's like 3 grand frameworks on offer that the technologists can consider to orient their work. That's not what I'm going to do. I don't think that's an especially productive first point of entry into thinking about the tools and resources that philosophy has to offer. And I also want to add that another feature of philosophical debate, AI ethics, from maybe 5 years ago, certainly from 10 years ago, is that the philosopher shows up on the scene and says something like, hey, technologist, can we think about justice for a little while? How about fairness, algorithmic fairness, and various questions about bias? Oh, transparency, accountability, explainability, legitimacy, a whole bunch of basic vocabulary that comes from the history of political and moral philosophy. And none of that is, especially in my experience, brand new to the technologist. It's not as if the technologists didn't have available to them the concept of fairness or the concept of justice or the concept of equity. And it's not especially helpful for the philosopher to show up with no technical training of any kind and then to say to the technologist, would you like to address questions of equity or fairness? There has to be some sustained exchange between them so that the philosopher takes on board some of the mindset of the technologist and the technologist takes on board some of the history of frameworks and resources that a philosopher has to offer to understand the content of those concepts rather than just the announcement of them. To give you a kind of cartoonish anecdote of what I think is the state of AI ethics maybe 10 years ago, at least at Stanford's campus, Stanford's computer science department would have a class on technology and ethics and would be taught by a computer scientist. It would have all kinds of interesting technical discussions and conversations. And then the Wired magazine article on the trolley problem in autonomous vehicles would be assigned. And that was the philosophical input into the conversation amongst the computer science department. And then the philosophy department would teach a tiny boutique seminar called Technology and Ethics. And it would be 3 weeks of Immanuel Kant, 3 weeks of John Stuart Mill, maybe a little bit of virtue ethics. And then you would assign the Wired magazine article on the trolley problem and autonomous vehicles. And that was the technical input into the philosophy class. And that's just a bad way to think about the potential marriage or integration of all these skills. So what do I mean by the 3 levels of ethics then? This is where I want to begin to orient you to at least my initial approach. I want to talk about 3 different kinds of ways of conceiving how it is that a philosophical conception of ethics can come to play a role in the training of technologists and the wider behavior of technologists in the world. I'll just call them personal ethics, social and political ethics, and professional ethics. what's personal ethics? Personal ethics is something familiar to all of us. It's the idea that you should have a moral compass. You should try to figure out what it means to live a good life. Personal ethics arises in every person's life. It's a famous Socratic maxim, the unexamined life is not worth living. It's just an invitation to think about how it is that you want to guide your life. And you can be a moral sleepwalker and just go with your intuitions, but that's generally not a recommendable strategy for living a good life. And the personal ethics approach is a fine one. It's what happens in universities when there are ethics requirements. The business schools of the world often have an ethical reasoning requirement that amounts to considerations of installing a personal moral compass for every person in the world and then sending them out. I do not think that personal ethics is an especially robust point of intervention for the work of a philosopher alongside a technologist. And that's in part because I don't believe that any of us are likely to become moral saints, always conforming to whatever our personal moral compass asks of us. And in fact, we should plan our world to assume moral frailty, moral imperfection, et cetera, et cetera. So personal ethics is maybe a fine approach, but hardly something to rest the case for humanity on if we're facing something as profound as these two grand revolutions, genetic editing, bioengineering, and artificial intelligence. And just by way of offering some examples of this, I mean, these are just garden variety headlines about how to think about Silicon Valley, the fake it till you make it approach, in which case people routinely seem at least to fudge the personal morality that they might otherwise bring in their interpersonal relationships when it comes to getting their investments. Does anyone really believe that if only Elizabeth Holmes had gotten the ethical reasoning course at Stanford, she wouldn't have gone off to do the various things that she was alleged to have done and then convicted of? And the same is true about other technologists who break the law, do things that are just obviously bad. Now, another way of putting this is that moral failures of a whole variety of kinds happen across every aspect of life. You can find this in sports. You can find it in politics. And in certain respects, what I want to suggest about personal ethics is that it amounts to something, at least in the kissing cousin neighborhood, of something as simple as this book that came out about 20 or 30 years ago. All I really need to know, I learned in kindergarten. Personal ethics does not provide any potentially controversial topics to talk about. There is no moral case on behalf of lying, cheating, and deceiving, faking it till you're making it, et cetera, doping yourself in sports, lying in politics. I mean, there may be some interesting Phillips of discussion on the side, but in general, there's no moral ambiguity. There's no moral grayness to this. And the most interesting kinds of questions from the standpoint of morality, of political philosophy, come where there are answers that are in the form of better and worse rather than true or false or right and wrong, at least in my view. And so many of the questions that confront us with respect to artificial intelligence come in that form as well. There aren't uniquely correct answers to a variety of problems. There are better and worse answers. So personal ethics is not going to be, in my view, an especially powerful leverage point for thinking about that. So that gets us to social and political ethics. And this is the main kind of orientation I take in my work as a philosopher. This is political philosophy. This is ways to think about what are the sets of either constitutional arrangements or laws and policies that will help coordinate the behavior of people who are very, very different, but are equally situated as citizens. How do we create a political community in which we find ways to respect and tolerate each other and yet be bound by principle to committing ourselves to that political community? That's the questions that arise when thinking about politics. What makes a democratic society a justifiable society, a better society than non-democratic ones? This is the domain of social and political ethics. And when it comes to AI, of course, this is just a set of questions about whether it's the FTC and various regulatory approaches of antitrust or other ways of trying to install rules. The EU, of course, is ahead of the United States in various ways and in various regulatory approaches. And that's the domain of social and political ethics. Now, often people think that exhausts the ways to think about ethics. There's personal morality, that's private personal ethics. And then there's political morality, that's political philosophy. But there's this important third domain, and that's where I want to focus our attention, which is on professional ethics. Professional ethics is, of course, about the standards that bind together people identified as members of a profession. It's a form in certain respects of self-governance that sometimes is backstopped by various actual laws and policies, but where those laws and policies emerge from the communal norms that come from the profession itself. Now, just one word about social and political ethics. I think there's a common phenomenon that if you look back at history happens, which is that on the frontier of scientific innovation, scientific discovery and technological innovation, wise regulation comes far behind on the frontier. And so we can't look, especially in the newest areas of technology and science, we can't look to governments to have especially wise forms of regulation. We have to look elsewhere. In the United States, this is something I was sort of surprised to learn as I did research for this class and then for the book, that in the 1990s, it was Bill Clinton and Al Gore. Al Gore, of course, the alleged inventor of the internet, who crafted a set of regulatory policies that were quite purposefully permissive or even indifferent to the development of industry in Silicon Valley. There was what was called a regulatory oasis so that the United States could win the race to pave the information superhighway. That's the language used by Clinton and Gore in the 1990s. And of course, the best example of that is the Telecommunications Act of 1996 and the CDA 230, one component of it, which established a regime of no liability for internet companies for the content that they host on their platforms. A deliberate avoidance of government oversight of the development of technology companies. Now, perhaps that was wise for the 1990s. I think we're long past the day where regulatory oasis is the appropriate approach to think about that. But in any case, the point is just the general matter that technology outpaces the capacity of wise regulation. And so instead, we have to look at professional ethics, is my claim, as an important lever for thinking about steering technology and science for social benefit in a responsible manner, especially when technologists and scientists have acquired great power in the world as they have today. So we're going to ask questions about what the standards are of behavior that coordinate and govern one's professional role. Here's the additional provocation I want to offer. I want to focus on a comparison between the history of biomedical research and sort of pharmaceutical innovation, and then compare it to computing. In biomedical ethics, you have a long-standing oath, the Hippocratic Oath of do no harm. You've got professional licensure requirements so that if you're a healthcare provider and you violate various standards of what counts as the responsible provision of healthcare, you can effectively be de-licensed or barred from then practicing healthcare. In any setting in a pharmaceutical company or in a university where biomedical research is taking place, there's an institutional review board that governs your ability to do research. When you have human subjects, you have to go through the IRB to get permission to conduct your research, and that includes an ethics review within it. There's, of course, a single agency, which is a strong regulator. We all know this from the success of the vaccines, emergency authorization by the FDA and other bodies around the world. You can't, as it were, tinker away in your garage, experiment with various therapeutics, try it out on your neighbors down the street, and then try to bring it to market. You have to go through this FDA procedure. And then finally, there's a massively developed institutional footprint of biomedical ethics that anyone in the field will encounter in the university as well as out in practice, hospitals with ethics committees, an entire scholarly field in biomedical ethics, et cetera, et cetera. What's the case in computer science? Well, the main professional body, the ACM, does indeed have a code of ethics. I'll talk about that in just a little bit. There's no equivalent of the IRB. If you're a data scientist, you allegedly don't work with human subjects, and so you're free to do whatever kind of testing you want to do, no permission required. Go figure out how it is that you want to do A/B testing in various ways, or just get up and running by scraping the web on whatever data you want and training a model in whatever way you wish, and off you go. And then, of course, there's no single regulatory body that exists to steer, govern, authorize any type of digital or technological innovation. This is another way of trying to suggest to you the field of biomedical research is older, more mature. It has faced various scandals. If any of you know the history of it, where did all these regulatory and self-governance aspects come from? Well, they came from the ashes of World War II, Nazi-era experimentation on human subjects in the concentration camps, and then the Nuremberg trials afterwards that tried to install much more rigorous standards of what counts as responsible medical research. And then in the United States, the Tuskegee experiments, the deliberate non-treatment of Black Americans who had syphilis, and another set of regulatory agencies that came up and self-governance approaches out of that. In computing ethics, we just don't have anything quite similar. So maybe one way to put this is that we can divide the world into carbon-based ethics, that's where it involves humans, and silicon-based ethics. For anyone doing biomedical research, the main object of concern is a human being, a patient. Those people are subjects of care, and the loose background norm is the Hippocratic Oath. For Silicon ethics, we don't have patients, we have users. Instead of being subjects of care, the people are most often objects of prediction, and there is no equivalent to the Hippocratic Oath, no kind of ritual that tries to bind people together as professionals. So you might recognize some of these people. I had the great privilege of bringing together two people whom I regard as pioneers, one in the field of bioengineering, the other in the field of artificial intelligence. The middle person there is Jennifer Doudna. She's one of the co-discoverers of CRISPR. On the right is my colleague, Fei-Fei Li. She's one of the pioneers in computer vision and the co-director of the Institute for Human-Centered AI. They came together to have a conversation a few years ago about professional ethics and how it was that these two revolutions could be guided by concerns about social implications and ethical sort of codes. And one of the things that since Jennifer Doudna shared this initially at this conference, and I'm sure she'd spoken about it before, if you've read Walter Isaacson's wonderful biography of her and the bioengineering revolution called Codebreaker, she shares the story there too. Jennifer Doudna had this extraordinary discovery around the same time that Fei-Fei Li put together ImageNet. Realized this CRISPR gene editing technique was extraordinarily powerful. And then she tells the story that she had a nightmare a few weeks later. And in the nightmare, Hitler appeared to her and said essentially, Professor Doudna, I am very interested in your scientific discovery. I want to understand the uses, implications of this amazing technology you deployed. She tells the story, Walter Isaacson tells the story, that after that nightmare, she woke up in a cold sweat. And the next day, she sent emails to gather together all of the top high-status biomedical researchers in the bioengineering community in order to have a conversation about trying to figure out prudent ways of allowing this extraordinarily powerful technology to develop, but that was contained and limited by various precautions about its potential negative uses, the dual use orientation. So a few months after that, this article was published in which there was an announcement about a voluntary ban on the use of CRISPR on human embryos or on human beings. Allow research to continue, but there was an effort to say, don't use this on humans. No law was passed. It was an announcement just by some of the top researchers in the field, an attempt to establish a norm of responsible conduct as someone on the frontier of this powerful scientific discovery. So what happened? A few years later, a scientist did, in fact, use CRISPR on human beings. It was this scientist who also spent time as a postdoctoral fellow at Stanford. That's why Stanford investigated there on the right about this. What happened when this researcher used CRISPR on human beings? No journal would publish any of his articles, and he was disinvited from any professional conference in which he might present his results. Eventually, the Chinese government imprisoned him. Leave that aside because that's the force of law. I'm interested in the two former things. The professional stigmatization of the researcher who had violated a voluntary ban on using human beings for CRISPR research. There's an example, a recent example, perhaps grown from the deeper history of biomedical research, in which the highest status researchers, Jennifer Doudna, of course, you probably know, went on to win the Nobel Prize just 2 years ago. The highest status researchers try to establish norms of what counts as responsible conduct and find various ways to enforce those norms through professional reputational costs, making it far more difficult for them to appear at professional settings. And again, leave aside the prison status. Well, what's the state of those community or industry norms in artificial intelligence? And one thing I usually say at this point is, any of you who are AI researchers, can you think of a single individual in AI who has done something beyond the scope of responsible conduct in AI and suffered a professional cost for it? Now, maybe these days we're beginning to tread slightly into territory. Somebody told me recently, Blake Lemoine, he says at Google, AGI is becoming conscious, and then he was essentially fired for that. I'm not sure that's a great example, but we can think of some others. What we do have in AI is company by company norms. So of course you have AI ethics standards galore, AI ethics frameworks proudly trumpeted by different companies. My own view is that if we have 100 different AI ethics frameworks for 100 different companies, functionally we have no AI ethics. Corporate standards alone have some value. They serve as good retention and recruitment tools for companies to hire people who are going to act more responsibly. But they leave society, because it's a company by company approach, in the same lousy place that we might have been without them. What do I mean by that? I mean by that this: Microsoft, like Amazon and IBM, made a decision based on its own AI ethics principles that it would not sell facial recognition technologies to police departments. Now, how did that leave society by this important and interesting decision based on corporate ethics standards at Microsoft, Amazon, and IBM? Well, you probably know the company Clearview AI. Clearview AI, treated by lots of press as offering up facial recognition tools of extraordinary power on handheld devices like smartphones. Here's the founder of Clearview AI asked about the implications of bringing such a power into the world. I have to think about that. Our belief is this is the best use of technology. This is people who just can, pick up their phone, scan their environment around them, and identify anyone around them with some high degree of accuracy. And Clearview AI happily sells its tools to police agencies. In fact, those tools were used after the BLM protests in order to identify protesters. You might be able to find some positive use cases. Ukraine purchased Clearview AI's tools to try to identify either dead Russian soldiers or dead Ukraine soldiers. My point here is the one that a lovely AI ethics standard by Microsoft, IBM, or Amazon still leaves us in a race to the bottom, because as long as there are other companies willing to do what other companies don't, society is in the same lousy place, because we have corporate standards, not industry standards, not communal norms. And that's where we need to get. I don't need to pick on facial recognition tools. My own view is that the use of various forms of facial recognition and algorithmic models to try to infer from face prints various aspects of personality traits or dispositions like criminal tendencies amount to a modern form of phrenology or scientific racism. These kinds of studies often get discussed in the press as having some concern, but to the best of my knowledge, no researcher who has designed such a study, carried it out, and published the results has suffered any professional cost for it. They continue apace. As I mentioned before, we have the ACM Code of Ethics. Well, what happens if you violate the Code of Ethics? Here's the answer. You lose membership in the ACM. What's the consequence of losing membership in the ACM? Does it mean you can't be employed? No. Does it mean anything about a kind of harm to your reputation? To the best of my knowledge, the ACM has in fact banned people from membership on the basis of violating the ACM code, with, to the best of my knowledge, no professional cost to them beyond losing membership. Does anyone in the room think that ACM membership is an especially valuable and important professional credential? Again, not to the best of my knowledge. This is a worthy code with absolutely no teeth attached to it. Okay, so rather than just complain and point out the immaturity of community norms within AI, let's think a little bit about what we can do about them. And here I want to get to some recent dynamics and then open up the conversation to all of you. You could think about something like "Don't be evil." Of course, Google's an original motto or mission statement since repudiated, but there's some variety of ways of thinking about a ritual in which when people graduate with some type of technical degree, they utter and pledge themselves to some professional oath. The ACM Code of Ethics, well, we could find various ways to enforce with teeth. Taking a page from the institutional review boards that applies to research involving human subjects, you can find various ways of doing an ethics and society review. If you've ever tried to apply to have a paper accepted at NeurIPS, you know that of recent years, there's an ethics component of that application. I've done some research on that recently because I thought, oh, that's an interesting thing, a high status professional society in which lots of AI researchers want to present their work, and you have to go through this ethics review component of proposing your paper. So far as I'm aware, not a single paper has ever been rejected on the basis of the ethics statement alone. And so again, I don't yet see any teeth attached to that, although it's a nice initial start. The Ethics Society Review is being pioneered at Stanford in HAI, the Institute for Human Centered AI. Any faculty member at Stanford who applies for a grant to conduct AI research has to go through an Ethics Society review. That's not a binding thing, so it's not as if the review board can overrule a grant-making effort yet. It's just an early pilot study to see what kind of dynamic emerges from this. Within big tech, you've got antitrust approaches. You could point to the EU, but this is back in the forum of social and political ethics, formal law and regulation. And then I want to talk a little bit about ethics education and computer science, the kind of thing that I think we're pledged to. Katie working on the embedded ethics program, the idea not that you should take a single ethics course somewhere else in the university that doesn't bear much relation to what you're doing as a technologist, but rather try to embed ethics and policy modules within all of the core courses of a computer science major. If you replicate that within bioengineering and other STEM fields, now we're beginning to approach a more integrated orientation to the training of technologists and scientists, and that might yield some professional norms. So I want to end then with a couple final observations about things that have really happened in just a past few months, and get your own effort here to discuss this with me. I wrote something a couple months ago with the title of this talk. This was just a short little blog post in HAI. It gives the provocation there, but AI is like a late stage teenager developing a code of responsible conduct, in part because I've been using various tools recently that I'm sure you have as well. These extraordinary language models, or at Stanford, we call them foundation models, image production, text production, video production now. I decided to punch into GPT-3, the prompt, should AI have professional norms? And you see there the output it gave, rather amusing. Maybe true, but also perhaps telling. You know the story about GPT-2 and 3 here in this room, I'm assuming, when OpenAI first developed GPT-2 and announced it in some 2019 papers. They talked about the dual or many potential uses of it, large upsides as well as large downsides, misleading news articles, misinformation, disinformation on steroids, automating the production of spam. And their release strategy was quite deliberate. They would limit access to the tool, and they would have various ways of further training the model so that it would refuse to output various forms of slurs or obscenities. And they trained it in a way that you couldn't produce porn through using GPT-3, GPT-2. So there was an effort here, admittedly just by a single company, but since this was the first mover in the marketplace, an interesting and important effort not to just release it everywhere all at once. Well, you know what's happening now. GPT-3, GPT-4, the arrival of stable diffusion and stability AI on the scene, Hugging Face, various ways of hosting all of the, not all of, but many of these large, powerful models, has shifted the orientation from one of strategic and restricted release to one that involves much more wider access for anyone to play with these powerful tools. When earlier this summer, a kind of prankster AI researcher trained a GPT-4 model on some horrible, vile subreddit of 4chan, and then released the model to the world as GPT-4chan, flooded a whole bunch of threads on Reddit and elsewhere with the output of this vile and racist and sexist language model. There were various efforts to try to deplore that effort. Hugging Face eventually took down the GPT-4chan model. I see that as an incipient sign of a recognition, at least of, in my mind, low-hanging fruit about what it is that the community should stand against. But stable diffusion has upended all of that. And so with respect to this powerful frontier technology right now, foundation models, and the extraordinary pace of innovation, like every 3 days, it seems like there's a new model with new powers, larger parameters announced. I feel like this is an especially urgent place to try to develop some community norms. I wonder what you think about all of that, and we could also point to other forms of frontier technologies. But with that, I want to bring my presentation, the provocation, to a stop, and invite your own questions and comments. So thank you.
So questions.
Oh, wow.
Yes.
Okay.
We have to do the microphone thing because of the video.
Okay, well, thank you. You can hear me, but
Yeah.
this is great. I completely agree. And I think it would be very valuable to have this type of code of conduct. But I want to get your opinion about kind of what limitations do you think it would have? Yeah. Obviously, there's the broader regulatory issues that are there, but also there's this other thing that one might think that in many of these cases, the problems arise because the computer scientists are kind of either do or ask to overstep their expertise.
Yes.
So in many cases, the product should be developed by a team that is interdisciplinary, yes, that is like involves participatory modeling and so on and so forth.
Yes.
And those don't seem to be the type of thing that fall within a professional code of conduct, yes, right?
Yes.
So what do you suggest for those type of things?
Good. I think that's an important question. And I agree entirely that a kind of supplement to something that's a code of conduct should be a set of professional expectations of what it means to develop an AI tool or a product or let's call it something that a technologist is doing in industry that begins from the team, the product team that's doing it, not just hot housing technologists together. One thing I often say is that I don't ever want to see arise a scenario in which companies appoint a CEO, a chief ethics officer, as if ethics was at the end of the development of everything and akin to legal compliance, and then no one else is responsible in the company for ethical questions, but only the CEO is. So yes, we should do that. And here's some language that I've been using recently just to try to prime that in a way with technologists, including the venture capitalists who tend to circulate around campus on occasion at Stanford. So phase one of what counts as the professional conduct of technologists in a company is that you should do quality assurance. You debug your code before you release it. And people have specialized training in order to do that in varied ways. Phase two is you get a subfield that emerges on user interface and user design. So now you have a debugged code base. You'd like to get many more people to use your product. The technologist alone, without any HCI orientation, is not likely to have all of the insights about human psychology and behavior to reduce the friction to the uptake of whatever your product is. And so you have a professional class of people who work in a company on user design. Phase three, now you've got a product that's used by a lot of people. You begin to see adversarial attacks or various ways to hack into your code base or with the security of your product. And so you hire people who are cybersecurity experts in various ways to guard against adversarial uses and hacking into it. And again, another familiar professional domain that people will actually hire for in a company. Optimistically, I want to say we're on the brink of a fourth wave of responsibility or professional responsibility, which something about ethical and social implications of technology, in which we'll have people trained, so we have to backward map this onto a set of training environments within universities, and that perhaps those will be jobs in trust and safety teams and responsible AI teams and integrity teams. They often get called different things, but that maybe become a routine part of what it means to build a product in a more responsible way. That's I think a hyper optimistic view, but I want to think the trajectory I described is roughly speaking right, at least with respect to the first three phases. So maybe we're ready for another wave.
All right, we're going to take a question
on this one. Let me follow up on this one. So I wanted to ask you actually, like everything including this conversation, everything you presented, how much weight is there really actually on the code of conduct? Because like now what you presented, what you just explained is more of putting the actual ethical reasoning, neither the personal ethics, nor the social, nor the professional, actual ethical reasoning into the development process.
That's right.
And when we think about the code of conduct, following your example from the biomedical and research, well, Hippocratic Oath predates all law.
Yes.
But because it did not really function well as a law, we have all this very elaborate medical law, right?
That's right.
And we have very well-developed medical ethics to accompany it. When we go to the research ethics, we have the code of conduct, but then not only we have all the tort and criminal, but we also have the common rule that you mentioned, Declaration of Helsinki, all of these.
Yes.
And the way that's like, to me, the function of the code of conduct, do we have any idea how it actually has a material impact apart from aspiration? And also connecting this to the part of the CRISPR story.
Yes.
You know, the ostracizing, well, we are giving the CRISPR story as a story because like 7 years ago, but there are not that many of those stories because it's very difficult to show the personal responsibility, right? Like who was responsible in making such a huge breach that it resulted in an ostracization.
Yeah.
And in AI, I would assume the assigning blame, especially in cases where it's like really high, the bigger harm, is going to be much more difficult. So summing it up, does actually the code of conduct have any real function apart from everything else that you discussed, which couches the code of conduct?
Yes, I want to say, of course, it can and it must. And I don't want to be heard to be saying we shouldn't also make enormous efforts to build regulatory, legal, policy frameworks that have the force of the law and the state behind it. My prediction is that those will come more slowly for some of the reasons I gave. And the idea that is traditional amongst technologists, especially the techno-libertarian approach, which is, you know, the less the regulation, the better. The regulation is another brake on progress, like philosophers who show up in the room with the computer scientists. And we should leave that aside. And there almost always comes along somewhere, you know, in that conversation. And if the United States or European Union regulates AI advances, then China, and off to the races we go about some geopolitical competition. So that gives me reason to think that it's all the more important in the current moment to try to accelerate the development of these community norms and industry standards. I can try to point to additional examples beyond the CRISPR one, but the CRISPR one illustrates at least the kind of teeth that they have, which is a kind of stigma or ostracization, as you put it. And in the history of the maintenance of norms, norms can't only be aspirational, a kind of carrot approach that you will get praise if you adhere to a set of common norms, but also sanctions. And in my experience, anecdotal, the technologist is far more likely to ask for standards that are aspirational and then to shy away from anything that involves sanctions. What kinds of sanctions? Well, ones that involve saying you should pay a reputational cost for the things you did. And I think I disagree with you, although maybe you should give me some more examples of what you have in mind about why individual responsibility is harder to make out within AI context, unlike the Chinese biomedical scientist who used uncontroversially, it was him who used CRISPR on a human. I mean, take the founder of Clearview AI. My view is that if you're the head of Microsoft, Amazon, and IBM, you should hope that venture capitalists don't give him more money at Clearview AI. You should say broadly and without any regret of any kind, the professional norm that we should uphold is one that has responsible limits on the sale of facial recognition tools to police departments or whatever it is. And the venture capital community would do better to disinvest from that. That's a reputational cost that it wouldn't be hard for anyone to announce trying to impose. It might be hard to actually bring it to bear, but the task of getting these norms up and running is to get a sufficient number of high status people to agree to trying to impose costs rather than just announcing aspirational standards. So take the researchers who do the, you know, criminal predictions or criminal tendencies on the basis of face prints. By my lights, those people should be less hireable in industry or in academia on the basis of doing those studies that seem to me some version of phrenology. And I would wish that computer science departments would see these kinds of research projects and think that's disreputable. That's not the sort of responsible conduct we expect from a well-trained computer scientist. And I could keep going in this manner, but you know, if anything, what I don't want to do is put the onus on it, as it were, the consumer or the user, because I think the tools that we have available to sanction or punish, other than not using a product, are very weak. And that's why it has to be in some form or fashion the responsibility of the wider community of professionals to try to police its own members.
I think for being responsible, I'll let the other questions, we can come back to this.
All right, thank you so much. We have about 5 minutes left. I just want to remind the people in the room that Rob is staying after, so we will get all your questions answered, not all of them, but some of them. And for people in the chat, If we do not get to your question right now, we're going to be getting these answers from Rob, and we will be publishing them on our website through a Q&A. But we will take a virtual question now.
Okay, I will read the question. This one is from Ricardo. So it says, Kosinski's phrenology papers, passed the Stanford IRB. Do you think IRBs should be reformed to become real ethics review boards?
Yeah, the Kosinski papers did pass IRB. I'm not 100% sure it was the Stanford IRB. There might have been some venue shopping that happened there, but leave aside that question. It did pass some IRB. And, you know, just as the GPT 4chan guy said, this was in the spirit of research into the negative uses of a particular tool or technology. And that in the absence of doing the research, we will not learn about the negative use cases. I'm open to that idea. However, there ought to be a way of thinking about the kind of research that Kosinski did that has some purpose-built approach that takes a page from the IRB that would allow, as a part of the questions asked of the research design, to wonder about the potential harms that could be imposed on human beings as a result of the research itself. And whether that means, you know, limits on publication. Like another thing I sometimes think is that as a political philosopher, I often get frustrated with the invocations of democratizing AI, which turns out functionally to mean nothing more than open access, an open source, a kind of approach to thinking about the development of any tool. And openness is just one of many of the core values of democracy. If anything, the core meaning of democracy is the idea of governance. And so the idea of democratizing AI has to mean, to my mind at least, something about the governance of AI. And openness itself is not a sufficient answer to that question. So I don't come prepared to offer up a kind of wholly redesigned IRB for the purpose of data science or AI research. But I like the spirit of the question that asks how we could install more regulatory safeguards within an IRB equivalent for AI and data science.
All right, we are going to conclude there for the day. Rob, thank you so much.
Thanks for having me.
Yes. Again, for our virtual participants, please keep submitting your questions, and we're going to get these all published later. And for people in the room, please enjoy some lunch and time with Rob. Thank you so much.
The Institute for Experiential AI is proud to invite you to our fall seminar series, featuring leading AI experts and researchers sharing cutting-edge ideas. You can expect AI leaders from a broad range of industries sharing perspectives on defining and applying ethical AI in our distinguished lecturer series, and EAI faculty and Northeastern University researchers discussing their AI research in our Expeditions and Experiential AI series. Registration is required, and the seminars are free to attend. We hope you'll join us for an invigorating fall semester. Up next, join us on Wednesday, November 16th, 2022 at 1 p.m. for a complimentary lunch and learn about the Foodome Project, tackling the complexity of food systems with Julia Menichetti, principal investigator at Harvard Medical School.